Okay, now the session is being recorded. We're gonna go over chapter 5 review. If you see the question, they're pretty much the same what you have on the assignment. So let me just start with the first part. The weight of adult males is normally distributed with a mean of 175 pounds and a standard deviation of 29. So mean is 175 and sigma is 29 pounds. First question, what is the probability that one randomly selected adult male will weigh less than 185 pounds? So you just start like that, probability of X less than 185 equals normal CDF. Every time you have a less than, guys, you have to start with a negative a million or billion. That's your lower bound. Then your upper bound is 185. Your mean is 175 and your standard deviation is 29. And let's see what the answer is using the calculator. Turn it on, go to second, variable, normal CDF, it's the second function. Okay, put a negative a million, put as many zeros as you want here, then 185, comma, then 175, comma, 29. Okay, the answer, let's say went around to 4 decimal places. So the answer will be 0.6349. For chapter 5 assignment, you're being asked to submit the answers using the form. Actually, if you click on the link for the assignment I sent you, it is the actual assignment and you submit the answers at the same time. Once you submit the answer, you don't have to be online to submit the answers. This is an offline form that you fill out, submit the answers, and you're done. Next question. What is the probability that one randomly selected adult male will weigh more than 190 pounds? Okay, more guys, it's like that. Normal CDF again. More than 190 means 190 and up. Up is infinity and 190 is the beginning. So 190 is your lower bound, 1 million, 175, and then 29. Let's see what this answer is. So again, normal CDF. There's 2 functions in chapter 5, normal CDF and inverse norm, that's it. And then 190, comma. If some of you have a newer calculator, just put 190 and then enter, go to the next line and put 1 million, go to the next line, put the mean, go to the next line and put the standard deviation. It works the same way, guys. 1 million, comma, 175, comma, 29. 0.3025. What is the probability that a randomly selected adult male will weigh between 170 and 200? That should be the easiest because it gives you the lower bound and the upper bound. Normal CDF. Here, 170 is the lower, 200 is the upper, and 175, and then 29. Okay, let's do this. Go second, distribute, normal CDF. Okay, 170 and 200. Oops, put 2000. 200, comma, 175, comma, 29. You notice mean and standard deviation don't change. 0.3741. If you look at the assignment, guys, you're going to notice pretty much the same question. One question is about x being less than a number, x greater than a number, x between two numbers. And now section 5.4, the central limit theorem. When you have a sample, you notice in ABC, we were selecting only one person. Now we're going to select a sample and ask about the sample mean, about x bar. So the standard deviation is going to change now. Suppose that 25 adult males are selected. What's the probability that they have a mean weight of more than 190? Okay. It's not X, guys. It's a mean weight, X bar more than 190. So anytime you have a sample, look what's going to change. I like you to watch the difference between part B and part D. Look, this is X greater than 190, one person. This is a mean greater than 190. So it will be normal CDF, 190, same thing, 1 million, same thing, same mean, 175. You see the match? The only thing is going to change, as you notice when I play the applet for the central limit theorem, when you work with samples, the standard deviation becomes smaller. So it's not going to be 29. You put 29, it's going to be wrong. It's over square root of whatever the sample size, which is 25. And that's it. That's the difference. So it will be second distribute normal CDF 190, comma 1 million, comma 175, same thing, comma, and now 29 divided by square root of 25, which is 5. Don't forget the division sign. And enter. See, 0.0049. What a big difference in the answer. All right, next one. Suppose that 36 adult males are selected at random. What's the probability that they have a sample mean weight of less than 168 pounds? Again, it's the same thing about X bar. Which is normal CDF, negative a million, 168, and 168, and then the mean is 175. And look at the standard deviation, guys, now. It is 29 divided not by square root of 25 because my sample size is 36. And you can do the math. F, what weight would place an adult male in the top 15% of all adult males? Top 15% of weight, that should go to the right. Most of the time, top means to the right. So this is the 15% right here. We need to know the weight of the person right here. So we need the X value. Okay. How do I do it? It's an inverse norm. And you need the area to the left of the targeted value. Since the area to the right is 15%, the area to the left is 0.85. Then you put the mean, which is 175, and then you put the standard deviation. Let me do this. This is not going to be normal, guys. It's inverse norm because he gave you the probability and he wants X, so you just go to number 3. And then you put 0.85, comma, 175, comma, 29, close. It's 205.06 pounds. Let's say, guys, you use the 15% to do this. I'm going to show you that the answer is not going to make sense. Watch. Let's say you use 15% instead of 85%. I'm just going to change the 8 to 1 and look at the answer. It's 144.94 pounds. So how could someone be a top 15% weight and his weight is less than the average weight, which is 175? That doesn't make sense. So you know it's a mistake. It should be 100% minus 15%, which is 85%. Okay, that is the a review for chapter 5, and that should help you a lot get the assignment done. If you have a good grasp of what to do and what to do on the calculator as well, it shouldn't take, you know, just a few minutes.